In this video, we're going to have a look at fractions, decimals, and rounding. Some fractions are easy to convert to decimals. For example, 8/10 is 0.8. 14/20 we can multiply the numerator and the denominator by 5 to have a denominator as a power of 10, being 70 over 100, and then converting to 0.7. Or even 5/8 we might realize if we multiply the numerator and the denominator by 125, we get 625 over 1,000, which converts to 0.625. These are all terminating decimals. This last example, we could have used a division algorithm if we didn't know that multiplying 125 will result in a denominator with a power of 10. For example, 8 is the divisor. Now 8 can't go into 5, so I'm going to put a decimal place and add some trailing zeros. 8 can't go into 5, and I'll carry up the decimal place and carry it over the 5. 8 into 50 goes 6 times. 6 8s are 48 with 2 remainder. 8 goes into 20 twice. 2 times 8 is 16 with 4 remainder. And 8 goes into 40 5 times, and we're finished getting the same answer of a terminating decimal. But not all decimals will terminate. For example, 4/9. 9 is the divisor. Again, I'll put a decimal place and some trailing zeros. 9 can't go into 4, so I'll carry up the decimal place and carry it over the 4. 9 goes into 40 4 times with 4 remainder. 9 again goes into 40 4 times 4 remainder, and you can see that we're in a reoccurring pattern. This is a reoccurring decimal and is written as 0.4 with a dot above the reoccurring digit. Let's take another example, 3 over 11. 11 is the divisor. Again, I'll put some trailing zeros. 11 can't go into 3, so I'll carry up the decimal place, carry over the 3. 11 goes into 30 twice with 8 remainder. 11 goes into 87 times with 3 remainder, and again you can see we're in another holding pattern. This time we write it as 0.2.7. We place the dots on the first and the last digit in the recurring cycle. For example, 1/7 would result in a recurring pattern of 0.142857, 142857, etc. We can write this as 0.1 with the dot above the first digit, 42857, and a dot above the 7. Another example is 5/12. 5/12 will result in a recurring pattern of 0.416666. It eventually becomes reoccurring. We can write this as 0.416 and the dot just above the 6. Rounding decimals. Suppose we want to round 12.3157 to 2 decimal places. That is, we want to come in and see if we can ignore all decimal places after the second digit. The 1 is called the rounding digit. Any number after the rounding digit, if it's 5 or more, will result in the rounding digit being increased by 1. That is, this number is closer to 12.32 than it is 12.31. So we round up to 12.32. Let's take the same number, but this time we only want to round to 1 decimal place. Again, the rounding decimal is indicated with the first decimal place. The number after it this time is 4 or less. That means we can just ignore all the decimals after the rounding digit. This will round to 12.3. That is, this number is closer to 12.3 than it is for 12.4. taking this example, again we want to round to 1 decimal place. It doesn't matter that all these 9 are trailing. The rounding digit is 4 and the number after the rounding digit is 4 or less. So we can just simply ignore and write this as 0.4. Now these rounding techniques also work with reoccurring decimals. 0.4 dot indicates that this number is 0.44444 continuing indefinitely. If we want to round to 1 decimal place, we can see that the digit after the rounding decimal is 4 or less, so we can simply ignore and round to 0.4. With this example, 0.3.6 the decimal would be 363636, reoccurring indefinitely. Rounding to 1 decimal place, this time the digit after the rounding digit is 5 or more, so this number is closer to 0.4 than it is 0.3, so we round up. And that is a nice summary of fractions, decimals, and rounding.